Alright, so welcome to today's lesson, wherein we are going to basically look at acid bases. And in our next video, we will combine that with salt. So the focus point today is going to be acids and bases. So again, happy new month of October. We pray that this month brings you smile, it brings happiness, it brings joy, and gives you that passion to love chemistry. Okay, so our tonight's topic, like I said, we are going to look at acid and bases. So our tonight's topic is going to be acid we say acids and bases, or we just say acid and base. All right. We know that this topic is a familiar topic from anyone, any high school student that have sat in Lowry properly, that passed through the world of Lowry, not the school passed through them, but that individual passed through the school properly. So I say, if you were asked by an individual what are acids and bases, what could be your response? We have heard about acid, sulfuric acid, hydrochloric acid. Most of we hear of sulfuric acid in a car battery. So here now you have been asked, what is an acid? Well, from the simplest definition in general, we can say that an acid is a substance that is capable of donating a hydrogen ion to a water molecule. So in general, we can say that an acid is a substance that is capable of donating a hydrogen ion, that is H plus, to a water molecule. Right? So what becomes of base? What are bases? Or what is a base? In short, we say that a base is something that they are like hydrogen ion, but that is not all. We have to go deep into acid and bases. We have acid and bases that can be defined, or that are defined based on three individuals. We have the Lewis acid definition. We have Lewis. We have Bronsted Lowry. And we have Arrhenius. So those three individuals define acid and bases in different perspectives relating to how they behave. Right? So for Lewis' definition of acid, he said that an acid is an electron pair acceptor. So this guy Lewis said, acid is an electron pair acceptor. So he said for acid, he said they accept electron or electrons as like this. It is electron pair acceptor. So how did he define base? If he have defined acid to be an electron pair acceptor, then it tells that base is going to be the opposite of acceptor. If you don't accept, then you donate. So he said that base can be defined as an electron pair donut. Electron pair donut. Again, Louis said that acid can be defined as an electron pair acceptor, wherein base can be defined as electron pair donut. So what becomes of Bronsted definition of acid? Like I said, we have three individuals that define acid in different perspectives. So for Bronsted definition of acid, he said that acid is a proton donut. Remember, this guy said acid is an electron acceptor, so they are opposite. He talks about electrons here, and this guy is talking about proton. So Bronsted definition of acid said that an acid is a proton donut. So it's a proton donut. Then, how this guy defined base? He said base can be defined, or he said base is, it's proton donut, so it becomes the opposite of this, becomes what? Acceptor. Acceptor. So I repeat, Bronsted said that acid is a proton donut and base is a proton acceptor. I can just put proton right here. He said base is a proton acceptor. Then, what becomes of Arrhenius definition of acid? For this guy, definition is the honest definition of acid. If you have heard about the Arrhenius equation, it was through this individual that brought about that equation, wherein you're discussing about energy and temperature, where as the gas constant, it's not gas rather, but our constant for energy will be 3.14. If you are doing the ideal gas equation, the value for hour change. So we have R to be a constant when doing gases, which will be 0.0821. And if you are doing energy, the constant for R will be 3.14, because you are dealing with energy. You're talking about joule. Okay, so that is not our focus for tonight. All right. So for this guy, he said that an acid is a substance that increases the concentration. I repeat, this guy said that an acid is a substance that increases the concentration of H plus in a water or an aqueous solution rather. He said an acid is a substance that increases the concentration of H plus in a water solution. So he defined acid as something that increases the concentration of H plus in a water or an aqueous solution. For base, he said that base is a substance that increases also the concentration of hydronium ion, which is OH minus, in a water solution. So if you hear about H plus, it talks about hydrogen ion. This talks about what? Hydronium ion. Excuse me. This talks about hydroxide ion. So this is hydroxide ion. When it is hydronium, it becomes H3O, have a plus right there. So this is hydronium ion. Sorry. All right. So now that we have learned the definition of acid, base, based on those three individuals. So now that we have learned the definition of acid, bases based on those three individuals, let us get something clear, because we have some keywords here that I think you have not clearly understood them. If someone says electron pair acceptor. What does that mean? Electron pair acceptor. In our previous video, we said that electrons is a species that contain mostly a negative charge. But in some instances, they have positive electron. When you are doing nuclear chemistry, you will get to understand that they have positive electron as well. But most of us about electron being negative, right? So we say electron pair acceptor. For this year word, Lewis. And I'm clearly sure that you have done the Lewis structure. So this is mostly talking about Lewis dot structure, about lone pair, For example, you have nitrogen to be in group 5. Nitrogen is in group 5. How many lone pair does nitrogen have? How many lone pair does nitrogen have? Well, it contains only a single lone pair because it's in group 5. So it has 4 bonds around them, or around it rather. So you have 1, 2, 3, 4. 1 to make it 5. So this now it becomes a pair. So this becomes a lone pair. So it tells that in most cases for nitrogen, it forms 3 bonds because those 3 you see here, they are vacant. They can still be bonded. So it was how you have ammonia to be NH3 because H can form 1 bond. So 1 bond of H comes here, 1 comes here, and 1 comes here. So they form this compound called ammonia as NH3. So it tells that this is a lone pair right here. So for Lewis acid discussing about electron pair acceptor, they are all electrons here. They are all electron at this. They are all electron. They are all electron. And we say a single bond contains 2 electrons, 1 here and 1 right here. Right? Okay. So that's just a clue on electron pair acceptor to gain. Right? And base we say is an electron pair donor it gives away. But we'll do more example on that when we are solving. It just a hint as this based on X definition. Alright? So we can reach to proton. We say Bronsted acid is a proton donor. If you have proton in acid base, we are discussing about hydrogen ion. And I did a video yesterday why hydrogen is called proton. It's very easy because this is an ion of hydrogen. To find the number of proton, we say P is equal to Z. And what is Z? Z is the atomic number. So the value for H is 1 and the mass number of H is also 1. So the atomic number of H is 1 and the mass number is also 1. So if we were to find a proton, it will just be 1 here, but this is what atomic number. Neutron is equal to what? The mass number, or we can say is equal to A minus Z. What is Z? The mass number minus the atomic number, which is Z. So what is A? The mass number is 1. 1 minus 1, it gives us 0. Right? To find neutron, we say neutron is equal to, excuse me, we say this is neutron, proton, neutron. To find electron, we say electron is equal to atomic number, which is what Z minus the charge. What is the atomic number of hydrogen? Is 1. And which charge does nitrogen have? It's plus, meaning what? 1. So it does an ion right there, so it becomes 1 here. You say 1 minus 1 gives us 0. So you notice that you have 0 neutron and 0 electron, but what? 1 proton. So it's how we refer to hydrogen as proton because all of those other guys contain 0, 0. For it, it's only 1. Right? And for hydrogen, it's in group 1. It want to give away, give everything. And in other words, again, it try to share the form bond right here. And you have what we call covalent bond because you're going to share, you found covalent bond right there. Alright, so it's a hint And for this guy, we say that Arrhenius acid, you can see H plus. This is what hydrogen ion, you see minus here. This should have been water, but it loses one of 8H. So it becomes negative. And we said that if you have a negative charge in chemistry, it tells that you can still accept or gain. There is negative, mean negative 1 here. So it was actually H2O. It was actually H2O. Let's say, for example, we have H plus bonded to OH minus. This tells that H wants to lose. If it loses, this guy here wants to accept 1 because it's negative. If you have a negative charge in chemistry, it tells that you want to accept. If you have positive, you want to what? Give away. Right? So it's opposite. Yeah. So this H here gives this to this guy, accept. It becomes what? H2O. When it says accept 1 more, so it becomes H2O. So it was how this compound was formed. And if you break this down for oxygen and that of hydrogen right here, if you do this, like you are saying, for oxygen is in group 6 and it has 6 electrons in its outer shell. So the first one it takes, we say 1, 2, 3, 4. 2 to make it what? To make it 6. 4, give a lone pair, 5, 6. 2 is vacant here. For H now, it can form any bond. It's form 1 bond. So here's the 1 bond of H right here. Here is H, 1 bond. So if H here and this guy, for O, we say is a non-metal, is a gaseous element. And for H is a non-metal as a whole, so they want to share electron. So if this guy share this 1 here with this guy right here, when you share, you have equal number of electrons now. So this guy has 1, 2, 3, 4, 5, 6, 7. 3 share, so if you're going 7, 1 more to make it 8. So here is what? It's still vacant. It can still be bonded. So for that reason, now this one you see here, it was how it got to OH minus. Meanwhile, you still accept 1 more. So later on, if you add 1 H here, then it becomes just H2O. There is no charge right here. So it tells that can ionize in water. It's only water. It ionize completely. Okay. So for this guy here, it talks about H plus and what hydrogen ion. Let's say example. We should not rush, or just hold on right there. We will do more about that. We should not hold on, we should not rush. Let us hold on and go grab something quickly. Okay, so if you were asked, what is the taste of an acid or a base? Acid. This thing contains acid. Like example, you go to the market, you try to get maybe an orange or a lemon, you tasted that. How do you feel about that? Something like, let's say, like, should we say bitter? No. Acid does not taste bitter. No, it does not. So for acid, it tastes sour. You're sucking the lime or let's say the orange, you say, that kind of a feeling or taste. So it tells that contained an acid. So lemon, orange, grapefruit, all those substances of fruit contain an acid because of its characteristic. Right? But get something clear. In chemistry, we do not taste things easily to determine if it contains an acid or a base. You cannot go to maybe in a company or an industry where they produce battery. You're going to taste what is in the battery to see if it will taste bitter or sour, to see if it contains acid or base. No, we don't do that. In fact, in chemistry, we don't lick the spoon. If I say that we don't lick the spoon, it tells that if you are using also a stirring rod to stir something in the lab, after doing that, you don't taste to see if it has mix. You don't do that. So when you are like cooking, after you stir the soup, sometimes you like take your finger and take on the spoon, you taste, oh, there's a salt. Yeah, it's good. In chemistry, we don't do that. We don't lick the spoon. We don't lick the spoon, no. We observe with our eyes, maybe based on color change, or reaction, or temperature, to tell us if this thing has occurred. But we don't lick the spoon to say, oh, this thing has been made, this, that. No. Chemistry, we don't lick the spoon. Alright? Okay. So we say for acid it takes sour. That's a fact. That's the fact of acid. It tastes sour. Base tastes better. It tastes better. And it also looks what slippery. The physical property of base is slippery. Once you touch it, it's slippery like spring. Spring is slippery. It's slippery, so it tells that it contains an acid within, it contains a base within it. And also, based on acid and base, we have something we call, you want to test for acid, if this thing contains an acid or a base. You usually do that in two ways. We have the litmus paper, we have the blue ones, and we have the red one, the red. But they are not typically red as you might see a red color, like something here. You must see this red color right here. You say, oh yeah, this is red. But it's somehow dim. The blue is somehow dim. Yeah, but they are all red and blue. So we have the red litmus paper and the blue one. So you use that to determine if a substance contains acid or base by placing them into the solution. And it will change to, if it is blue, you put that there, change to red, if it's red, change to blue. If not, if it is neutral, it will change to any color based on the litmus paper, right? So you can just go about to remove on which color of change a litmus paper gives you, if it is acid or base. That's just very simple. And we also have something we call the pH chart. What is pH? What is pH? Mostly our Liberian girls, African as a whole, if you say, oh, pH, those Facebook people, they refer to pH as foam. So, oh, foam. But as a chemistry lover, as a chemistry student, you see that as the power of hydrogen or the potential of hydrogen. It's not foam. Foam is spelled as pH or Ne, but for this is the power of hydrogen. So pH stands for power of hydrogen or the potential of hydrogen, right? So we test for acid and base mostly based on two ways, like I said, either by using the litmus paper or by using the pH chart. And we said that for that, the pH chart it ranges from 0 to 17. So it will tell you the value of acid or base in that particular substance. So we can say for instance, this is a pH chart, and 0 being a neutral one is 0. There's origin is 0. It's origin. Where I'm standing right now is origin. So if you look right here, we say it ranges from 1. So this is a pH chart. This is the pH. Always write small p and B-ish, right? pH chart or a chart or scale. So this tells us that it is red. Yeah, it do. So this tells us that the pH chart ranges from 0 to what? To what? It ranges from 0 to what? To 14. So here is the origin, but this cannot be 0. Though is the origin, but this cannot be 0. Based on the normal line, this becomes the origin, but based on acid and base, this can be 0. So this is going to be 7. So this going to be 7. Why? You will understand what 7. So we said 0 here as the origin right here now at the beginning point. But this is the demarcation separating John from Paul or Paul from John or acid from base. Okay, so here now this becomes 14. We said the pH scale ranges from 0 to 14. Right? So that is 0, that is 7, that is 14. Why do we have to put 7 here? If it says 7 times 2, it gives us 14. But where the 7 came from? It's kind of easy to understand that. Just paying attention. We say that this is 0, this is 7, this is 14. Logically, it tells 7 is neutral. If you do a test in a lab or maybe at home and you get to notice that the value of that particular substance is 7. Example, I would say, or neutral water, it tells that that particular substance does not contain either an acid or a base. It's neutral. Example, you see people making knocks in Raleigh. You have nothing to do there. You pass and go. You are neutral. If police comes, they won't catch you. If people come to fight, they won't see you there. You are neutral. You have taken no part in that reaction. You are not, say you are catalyst somehow. You took part in the reaction by seeing them or by passing by them. But you have no effect on that particular reaction or that particular noise that was being made. No, you are not. You are not. Right? Okay. So if you do a test and you contain a value of 7, it tells that it is neutral. It does not contain acid or base. And we say for acid range from 0. Acid range from 0 to 6.999. Acid range from 0, we can put acid right here. We can put ACID. That tells that acid range from 0 to 6. It reads from 0 to 6.999. Why? It is because once it gets to 7, it becomes neutral. It's neither an acid or a base. So acid reads from 0 from here to 6.999. So we say it's acid. When it's 7, it becomes neutral. Then when it crosses 7, I would say 7.00. When it crosses 7.00, it reaches to 7.01 upward to 14. That becomes a base. So that becomes a base. So this now, it becomes a base. So don't say base range from 7 as I said it. No, it's a 2. Nope. Base range from 7.01 to 14. Because once it is exact 7, it tells that that is neutral. It's neutral. So logically, if you look at this particular chart here or this diagram, what does that show or tells? It simply means that the lower the number of an acid, the higher the strength of the acid. The lower the number of an acid, the higher the strength of the acid. Vice versa. Here, let's say on the opposite rather, the higher the number of a base, it tells the higher the strength of that particular base. As you can see here, let's go to acid right here. We say the lower the number of an acid tells us the higher the strength of the acid. So if you have an acid or a substance that contains the pH of 0.21 and John has 3.5 as a scale value. So in other words, you have strong acid within a substance, you have the John. Because here now 0.2 is almost close to this. But here the come here is not far to reach to 7. To reach to 7 here is not far. So once it reaches to 7, it can be neutral. It loses its strength. When it's 6.4, it loses its strength. 6.9, it will be weak. It will be weak. The strength of the acid will not really be strong. It will be like weak. So mostly for sulfuric acid, you don't see them around 6. No, because they are a strong acid. You don't be around them. For weak acid, then you will see them around them. But for sulfuric acid, they won't be around 6. No, 5. No. It tells us that the lower the number of an acid scale or pH, the higher the strength of that acid. And the higher the strength of an acid, the lower, the higher the number of an acid, it tells us the weak the acid is. Like we have 0.21 of an acid value, and it has 3.5. So this is much stronger than this. Why? Because this left with like, let's say 2.5 to make it 7, and this level more to make it 7. So to reach to a neutral stage, you see how much difficult. I repeat, the lower the value of an acid, the higher the strength of that acid. And we say bearing from 0.1 to 14. And you have, I would say you have 8. You have 8. And I would say like you have 8 right here. You have 8. Then John get 20, then John get, let's say 11. So your base value or the pH value is 8. So what is 8? You know, say that base. You don't have to tell you the other thing base that. It's the pH value of this thing is 8. You know, say it contains base, right? It contains base. So we say the smaller for the base here, we say the smaller the number. The smaller the number. The smaller the number of a base or a pH, let's say base rather, the smaller the number of the base range tells us the strength of what? In this case, what would that be? You have 8 right here, you have 11 right here. So when it's 8 and this other person have 11, which one is strong and which one is weak? So this become the weak one. This become the weak one because from 7 here, from 8, you go to 7 right here. But for this a little bit far. This is far from this right here. So the higher the number of a base, it tells all the strength of that base. The lower the number, it tells you the weakness of that particular stuff. So it's opposite to this. For this, I repeat, the smaller the number, the higher the strength of the acid. So for base, it tells us, in this case here, the higher the number, it tells us the strength or the strong that base is. Because here to come here is far. But from here to come here is also far too. So it has 0.1 and I have 3.5 here. So this is far. 0.1 there is far. To come to 3.5, they can still get in between. We'll come to 7. So the lower the number of acid tells or the strength or the higher the strength of that acid. So for base is opposite. Hope you understand this from this scenario right here. Any question? Let me know in the comment section pertaining to it. If there's any clarity here, then just let me know. I'm going to solve that for you. Thank you. Okay. So we will move to conjugate acid and that of conjugate base. So this video is going to cover almost everything about acid base calculation. In our next video, we'll do like acidity of base. Talk about mono base, di, and tri. Talk about all of that in our next video. So we will move to conjugate acid and conjugate base. We will move to conjugate acid and conjugate base. I think we have all heard about conjugate. Conjugate. We'll discuss conjugate acid and base. We'll discuss about conjugate acid and conjugate base. I'm not discussing about just a conjugate verb eat. I eat, you eat. No, that's not what I'm talking about. I don't teach English, but I do English. Right? So, right here, we are going to look at what conjugate acid and conjugate base are. They are very simple to understand. I'm going to give you a very, very simple definition, and picture to capture in understanding conjugate acid and conjugate base. So they are like opposite, right? So for sure we can say that when an acid donate means to lose. If I have 20 letter, I donate 10, I lost 10. John has nothing. So he received that 10, he has accept. So John becomes the base, I become the acid. We say for posternary definition of acid, say acid is a proton donut. So I become the acid right there. I lose 10, John accept 10. So John become the base, I become the acid. So relating to that, we can divide conjugate base as, we can further divide conjugate acid as, we say when an hydrogen or a compound accept hydrogen ion, Alright, so to divide conjugate acid, we can say it. When an acid donates or loses an hydrogen ion, it forms a conjugate base. When an acid donates, when it gives away, when it loses this H plus, it forms conjugate base. So we can say also that when a base accept hydrogen ion, it forms what? Conjugate acid. So they are like opposite. So we can say that acid forms conjugate base. A base form conjugate acid. When an acid donates or loses hydrogen ion, it forms conjugate base. Get that clear? And when a base accept or gain hydrogen ion, it forms conjugate acid. So it's very easy to understand, right? I hope I'm making sense. All right. So we can move to strong acid and strong base. Then from there we can solve problem. So this video is for you. You need to understand acid and bases, so you can be able to solve problem on them. Once you watch this video, it tells how you have understood acid and bases like to your fingertip, right? Okay, so in doing acid and bases, we have to know some strong acid and strong bases. Like acid sulfuric acid is one of those strong acid. So we can say strong acid, we can put them right in the comment because we will need them when we are about to solve. We will need them when we are about to solve. So we can say strong acid, strong acid. All right. So if you are to get strong acid, number one, mostly you say sulfuric acid, which is, we can say H2SO4. Then we have something we call hydrochloric acid. Is also a strong acid. And we have something we call chloric acid, HClO3. And we have perchloric acid. So we have perchloric acid to be HClO4. And also we have something we call, like, we have hydrobromic acid. Hydrobromic acid, we have HBr, and we have hydroiodine acid, HI. So we have 1, 2, 3, 4, 5, 6. So mostly there are 7 strong acid. So what is that? The last one, what is that we are missing? We have something like nitric acid. Yes, we do have. So this become it become HNO3. So this become nitric acid. I can erase this out so you can show clearly. So this become HNO3. So what have we understand or observed so far based on those strong acid? What is that? We will notice that, or we have noticed that all of them begin with what? With H. Because the acid is a proton donor, and protons is mostly referred to as, let me say, hydrogen is mostly referred as what? Proton. So you have H all here. So for base, you will always see OH minus. You will see OH rather when they are strong bases. So acid contain H, bases contain OH, right? Okay. So right here we can label, we can scratch that right here to say strong. We can say strong bases. Yeah. So strong bases, what's the first one we know of strong base? We have element in group 1 that is called lithium, right? So if we bond that with hydroxide ion, we have something we call lithium hydroxide. We have something we call potassium. Potassium, which is K in group 1 of the periodic table, so it becomes K OH. What the next one we know? Sodium hydroxide. We have NaOH. And what the next one we know again? Element in group 1. What is that we know? Element in group 1. We have something like cesium hydroxide. Cesium hydroxide. So CSOH. And again we have element group 2 that has the atomic number of 20. What is that? We have like calcium. So it becomes calcium. We can put parenthesis open, OH equals to 2. So we'll tell you how this compound was being formulated. It's just easy. And we have something again we call element in group 1 called rubidium. So it becomes RB. So RB, rubidium hydroxide. And again we have 1, 2, 3, 4, 5, 6. We need like 2 more of them to complete. We have element in group 2 called barium. So we say Ba, parenthesis open, OH equals to 2. So we have 1, 2, 3, 4, 5, 6, 7. So what's the last one to make it like 8? We have sodium hydroxide, we have lithium, potassium, we have cesium, calcium, we have rubidium, barium, and what becomes of the last one? The last one should be what? Element in group 2. Group 2, the last base should be strontium. It should be strontium, SRL. Parenthesis open, OH equals to 2. Okay. So these are basically the 8 strong bases and 7 strong acid. You have to know them, right? We have sulfuric acid, hydrochloric acid, chloric acid, perchloric acid, hydrobromic acid, hydrogen acid, nitric acid, lithium hydroxide, potassium hydroxide, sodium hydroxide, cesium hydroxide, calcium hydroxide, rubidium hydroxide, we have barium hydroxide, and we have strontium hydroxide. Okay, so what's the next one right there? We want to compound. We want to bond. We want to write like an equation. If this is acid, this is base. If this is conjugate, if this is conjugate acid, conjugate base, we can do that. So we can look here on those acid and bases to pick and make a reaction. Where we have product and reactants. Alright, so if we are to pick logically, let's say something first. we have something called neutralization reaction. Neutralization reaction is the reaction between salt, or the reaction between acid and base that produces salt and water. And we haven't discussed about one thing that I've noticed is that we haven't discussed about is strong acid and strong base, weak acid, weak base. One like strong acids, those acids are acids that ionize in water completely. They get broken. When you hear about ionize, it tells that something that get charged. You get the ionize, ion get charged. So strong acids are acids that ionize in water completely. They dissociate. A sonic dissociate tells that it gets separated, it decomposes, it falls apart. So strong bases does the same. Do the same rather. Strong bases do the same. They are bases that dissociate or ionize in water completely. Unlike for weak acid and weak bases, they do not ionize or dissociate in water completely. They do that partially. We will give problem on that or on them to understand them better. Okay. So now we want to form a compound. Not a compound, but an equation. If we had to take hydrochloric acid first, let me say this. If we had to take this from right here and we add it to this, so we say that we have HCl plus NaOH. We have HCl plus NaOH. We have HCl plus NaOH. This is a strong acid and this is a strong base. If we are to react them together, what can we produce? Remember we said, based on Bronsted definition of acid, he said acid is a proton donut. It gives away hydrogen. And for base is a proton acceptor. It gains hydrogen. So in today's solving, we will basically look at Bronsted definition of acid and base and that of Arrhenius definition. For the weak acid, we will do another video on that because it's kind of long. You need to have the clear concept because this video is going to be like maybe long, right? So we say acid is, you have to pay attention because this is the actual point. Or what I've been saying is something you have to read and understand. This you have to get the concept how they can be formed, right? So this is an acid and this is a base. We say for Bronsted definition, you say acid is a proton donor. They donate, they give away hydrogen. So this is an acid. So it tells that this acid it has to lose what? The H you see right here. This is a base. It has to accept the H, which is the proton. So it means that this acid it gonna give this H to this guy, to this base right here, it accept it. So if it does that, what's the next step? If you have one H to the base here, and you accept the one H here, get this clear? You have one H right here, and this guy lose the one H to you, accept it. So you have two H. So only see your left right here. If you have two H to one, what you produce is water. So you can put plus, you can put H2O. If you produce water, then what left here is Na, which is sodium. This element is in group 1, sodium is in group 1. What you want to do? You want to lose electron also. So if you have this here, you have already lost this particular H. This H has been lost to this guy here, to this particular base here. But we say for acid, they donate. It means they lose H and base accept. So this particular compound only accept one H. They only have one H here, but accept one will make it 2. So it will produce water. because it has O here, because it produces H2 1 here and 1 here, become H2 and then O right become water. Then you'll be left with this right here. You'll be left with this. So here it tells that this will bond with this. It produces sodium. Because this is in group 7, it wants to accept 1 electron. This want to lose 1 electron, so they form bond right there. Understood that? So this become now, it become Na. It become NaOH. So NaO, excuse me, rather, it become NaCl. It become NaCl. So NaCl is a salt. This is water. And we say that the reaction between an acid and a base that produces salt and water is called what? Neutralization reaction. So this is a neutralization reaction. So most of the acid reaction talks about what? Neutralization reaction, because most time they produce salt and water if you are adding them with strong acid and strong base mostly. So this become a neutralization reaction. Yes, it is an acid-base reaction. You can see also. We go one loose and one accept. So the next step is you are told to identify the conjugate acid and the conjugate base. So first we can say this is a strong acid. We can say SA. Strong acid. We can say SP. Strong base. So the next step is to identify the conjugate acid and the conjugate base. Remember we said that acid forms conjugate base, base forms conjugate acid. And we said that when an acid donates or when acid lose H, it forms conjugate base. And when base accept H, it forms conjugate acid. So they are like opposite. Right? So in this scenario, as you can see right here, we have identified the strong acid and the strong base. So now we have to identify the conjugate acid and the conjugate base. This is an acid. When it lost H, it lost the H here, you see here, it lost it. When it lost H, what left there? It was Cl. So it was this Cl that left right there. Cl left there. So here now, the acid has lost H, and we said when an acid donates or lose H or a hydrogen, it forms what? Conjugate base. So the acid was HCl, but later on it lost the H. NaC here, right? You didn't see Na right here. So the H it lost right here now. So this right here, it become the conjugate base. Because we say acid form conjugate base. When acid donates or loses hydrogen ion or H, it forms conjugate base. So the product when an acid loses or donates H, that product, what is being formed is the conjugate base. So that is a product that was formed, right? And we say that when a base accept or gain hydrogen ion, that product when it accept or it gain, I have one marker. Then they don't accept one more. It becomes 2. So this product become the conjugate base. So acid form conjugate base, because if acid lost 1, the one is being formed, it become what? A conjugate base. Let's say for this guy here, for what's the marker tab? For this guy here, for sodium hydroxide, for this guy, you need to get 1 H, which is this. And you accept one from hydrochloric acid. One and you accept A. It becomes 2. So this that is being formed become what? The conjugate acid right here. We say base form conjugate acid. Acid form conjugate base. So the product of an acid become a conjugate base. The product of a base become conjugate acid. Hope you understand what I'm saying. So say it lost H, the product now it become what? HCl, the conjugate base. Then accept H by form water. So this become the conjugate acid. Isn't that easy? It's easy. So again, we can move to another example. Like we can say we have compound like the same thing. Should we say potassium? I would say we have the same thing here. HCl we have plus no, I would say we have potassium oxide. They say identify the conjugate acid and conjugate base here. So first, this is a strong acid. So we say SA because it's part of those strong acid. And the base 2 is there. So it is SB strong base. So yeah, it's very simple again. We say acid always lose. They lose H. So this H here comes right here. You accept it. So what I produce here, you have one H here, one H here. It becomes 2 here to 1 O. So it forms water. So this becomes plus H2O. What left here is Cl. After you lost the H here, what left here is Cl. Cl left right here. Cl left right. You have been left with Cl. And you have been left with Cl to the acid side. What left to the base side? It's only K, right? It's so K left here. So we are left with K. We are left with K right here. We are left with Cl. Because here now combine this to this, it produce water. We left with K and Cl, so this becomes potassium chloride. So it becomes KCl. You can still decompose the compound here to see how it will form. It's easy. It tells that potassium, potassium is in group 1, so the charge is positive. If we add out the chlorine, just what? In group 7, we put negative, it forms one KCl. 1 and negative. So I say plus 1 minus 1. Why give it 0? So the net charge is 0. So it will have the compound form. So you see no charge here. There is no charge right here. So it's because 0 right there. So what how this compound was being formed. You see with this, you do what I start now, it's very easy. So let's look at something again we call like amphoteric substances. What are amphoteric substances? We can say that amphoteric substances are substances that behave as acid and base, depending on its reaction or where it has been placed. Like example, water. Water is not always neutral, but it's based on where it's been placed. Right? So that would say for Eastern. We look at do you know very well that we can reverse this reaction? That you bring this so and you bring this so you tell that this is going to lose one of the H. Right? Okay, you can do that. So let's say example 3. We look at amphoteric substances. We say amphoteric substances are substances that behave as both acid and base. Example, we say water. So assuming that we have an equation that says, that would say, if you react the same stuff here, HCl. If you add HCl plus water plus, let's say, H2O. So if you add HCl to water, what will you produce? If you add HCl to water, what will you produce? So key concept right here. You should pay key attention to this particular 3. Okay. So this is an acid. And it is a strong acid because it's formed to the 7 strong acid that we know. But if you look here, H2O, it is formed here on HCl, no. So this becomes a weak base. So we add this strong acid to weak base. What will you produce? Mostly you see a charge. It will contain a charge inside or an ion. So here now, if you look at this here, we say acid, it want to donate. It must donate by all means, it must donate. So this acid is here, it lose this particular H to this guy here. It accept it. It become what? H3. It become H3. 3Y, 3O. But you know fully aware that in a compound like this, it can work. Because O can only form 2 bonds. Then why you get, or why you have 3H connected to 1O? It's not possible. We only form 2 bonds. So you can have 3H attached to it. That will say that draw it properly. So you can understand what it is teaching. We say here now O is equal to 6. It has 2 lone pair. So 1, 2, 3, 4. We say it has 2 lone pair. 4 is equal to 6. So it has 6 electrons. So we say 1, 2, 3, 4, 5, 6. So there's a 2 lone pair. It's a pair, it's a pair. Then the 2 F again, you follow boom. So you put 1 H here, 1 H here. How much H left? And you already feel, right? You can put 1 H here, then leave this out. It's not possible. So only form 2 bonds. But now you have a 3 H connected to 1 O. It's not possible. So in short, or in so doing, you have to put a charge right here. You put a charge here. Telling you that this compound you see here, it can lose 1 electron to obey the rules. It can lose 1 electron to obey the rules. So you must always put charge right here. Telling that all this thing here, what's the number you want to give away? You want to give away one of the H here to satisfy the rules. You know, the OTL rule or the duplex rule. Because you satisfy the duplex rule to the OTL rule, right? So plot is being placed here now. It won't lose again. Still lose 1 H to B1. When you lose 1 H, you produce H2O. Then will be correct. And then plus and therefore you can still lose. Then you say plus. So here now, because of this right here, if you lose the H here, what left here? It will be Cl. So Cl now, it will get a charge to it. Okay, negative charge right here. Meaning what? It can still accept 1 mole to form a compound. So it was how this negative charge in the bar right here. So in this case, the water here is serving as what? As a base. Because it accepts proton or hydrogen. It accepts it because 3. So this is strong acid, and this you see weak. This is weak base because it's not part of the cell of the 8 bases. You not see it here. Once a part of the 8 here is weak, one part of the cell here is weak also. Can I clear? So now is that identify the conjugate acid and conjugate base here. So we say if acid donate, just for him. If acid donate or if acid lose H, it form what? Conjugate base. When acid donate or acid lose H, it form a conjugate base. So the acid lose H, what the product of it when it lose it? It was only C here, right? So this now, so this become the conjugate base. We say acid for conjugate base. Then we say when base except or gain H, what it form? Conjugate acid. They want to accept or gain. So this become the conjugate acid right here. So let's look at one more example and close. I'm kind of tired. So we can read one example. We can read one more example. Let's say number 4. In number 4, I want to look at ammonia NH3. I would say NH3 bonded to water, to the same water. We are discussing amphoteric substances. How would it be of acid or base? Here now, if you are reacting ammonia to water, what do you produce? What will it produce? In this case here, ammonia is forming. It's funny where if you have nitrogen and what? H inside it. It tells that nitrogen is in group 5. So you have 5 electrons in the last shell there. You get 5 electrons there. So it's like this. You have the circle like this. And you have 1, 2, 3, 4, 5. There's a lone pair going a pair. How much figure 1, 2, 3. So you form 3 bonds. How about H, the H will form one bone. So each H will form one bone. If you have 3 H, will form 3 bone. So here now it means that nitrogen like this, you see that this, you see that this. So one H will come here, one H come here, then one H come here. You have a lone pair up here like this. A lone pair. When you do just you have a lone pair right here. Right? So that's what I mean right here. So if we add this to this here, I will produce. We said this here and this, they are all weak. They are all weak because you see here, you see any of them here. So you are both weak acid and weak base. Because you see them right there. So for here, this 7 as a weak base to strong acid. So this not going to serve as what? All this serve as this should serve as a weak acid, right? That will see it. That will see how is that done. For this guy you see here, for this edge you see here, and you have something like this. So here you have, we can read this guy, we bring this guy right here. We can bring water, but it's still okay, it's still the same. So this guy is here like this. What I'll say, this gonna lose one of its H. The H you see here, it will lose 1 to ammonium. It will accept it. Then it will produce NH4. Ammonium only form 3 bone. So you have 4 of N. You have 4 attached to N. You must pour charge there. Meaning what? It can still give away 1. If you do that, you say plus. What level A now? You either lose 1 H here. What left here? It will be OH. OH can stay by itself because it should have been H2O. Say A reach H2O for 1 charge here. You can still accept 1 more to make it what H2O. So that's just it. And thank you for watching. I'm very tired. It has been more than 30 minutes. So thank you, and I hope you understand. Any question, let me know in the comment section. I will reply to that. Thank you. I'm tired. What? Shit. What's the time? It should be 12. Thank you. Good night.